Thank you, everyone, and for the folks online, welcome. And I keep changing the title of the talk, so this may not be the title that I sent you, but the content is essentially the same. So how many people have played with ChatGPT here? All right, most of you. Okay. What is it? What is generative AI? When I was writing this talk, I decided, why not ask generative AI to tell me, what is generative AI? Summarized in 2 to 3 sentences, and it summarized it to me. I don't need to read it to all of you because we all have some intuitive experience with generative AI. Oh, by the way, I'm not sure where the mic is coming from. So, folks, if you're online, folks, if I wander away too far, please remind me to get back closer to the mic. All right. So, but I wanted to tell you a little bit about what's under the user interface. What's the language model doing under the user interface? This is in the early days before ChatGPT became a web application. You have these type of interfaces, and this was back in GPT 3.5. What this is a completion model. This is closer to the base of large language models. The completion model does this thing. It says, put very briefly, large language models such as GPT 3.5 tries to predict. Then you set all those parameters and you say generate. What large language model does essentially is that based on all of its training, which is based on the entirety of the internet essentially, tries to predict what comes next. It says, oh, given that you said these things, the most likely next word behind predict is probably going to be the, and then next, and then word. It predicts one word after another. And this is a recursive process. So once it predicts the next word is the becomes the prediction, the basis of the prediction. And then based on these plus the, it predicts next. Based on everything plus the and next, it predicts word. All right, so the most likely next word that follows is, of course, is. This is what goes under the cover, under the hood. And the minute I saw that application, the minute I got to play with it, I figured out an interesting use case, interesting simple use case. For example, in physics, we wanted to. How many people teach physics? How many people have taken physics? How many people don't like physics? I hope the physics today. I get it. I'm a physics education researcher, and every time I go to a party, I say what I do. People goes, ooh. Hopefully, the physics I tell you today doesn't bring back that. In physics, we write all this a lot of these kind of problems. Like you have a steel cable attached to top of an elevator pulling upward, and the key is that the elevator is moving upward and speeding up. It's already getting confusing. The tension in the cable is greater than, less than, or equal to the force of gravity on the elevator. Typical physics problems. Now, there are many different ways that you can, there are a couple of different ways that you can change the problem, and there are many different ways that you can rewrite the problem, but the core is the same. Something is going either up or down, and you have the direction of acceleration being up or down, and then you ask about the tension in either the tension or the supporting force. Traditionally, every time we want to rewrite this problem, we have to type word by word into learning management platform. Now, with GPT, you could do this. You could give problem stem, velocity up, acceleration down, steel cable pulling elevator. And you say, what's the most possible next paragraph that follows? GPT is going to write a problem that it thinks that the most probable, the elevator is now moving upward, but slowing down. It actually turns acceleration down into moving up and slowing down. Not only did it rewrite the problem body, it also writes the solution based on a couple of examples that I gave. All right. You can also do. It doesn't always work. Sometimes it makes mistakes, but you can change it. So, for example, I wanted to write the steel cable attached top of an elevator problem, into force of basket on cat. All right, a cat in a basket hanging. A cat is in a basket hanging from a window. GPT is actually very good at writing, changing those contexts. You put anything in a basket hanging from a window, you can hold a box, lowering it. It will do most of the writing with the human changing a couple of words. Now, this is a very, very straightforward application of GPT, which shows you at the basis what it is doing is that it is predicting the next word. And if you give it enough information, it can predict the next paragraph. All right. So before I go on to the next application, which I'm going to talk about more extensively, I wanted to bring up an important difference between human thinking and large language models. For humans, language is a symbol of thought. What does that mean? We have some thoughts in our brain, right? And then we have a language network. Whenever we receive a task, teacher gives you homework. We use the language model to process that symbol, and then we create a cognitive model in our brain. And then our language network tries to symbolize the thoughts into language again, which leads to an action. If you don't believe that the thought is separated from symbol, try to do some metacognition, look at your own thoughts next time you sit down and start writing something. And whenever you are like, I know exactly what I'm going to write, and then when you start writing, you can't find the words, that's what's happening here. Cognitive areas are all working. The language network is having a hard time finding the next word, which happens to be all. And this is what happens in the brain. There's language, cognitive language. Large language model thinks very differently. When you give it a task description, it breaks it into tokens. It's roughly half or a third of a word, depending on how long the word is. And including white spaces and all kinds of spaces, which is why it doesn't care if you give it math symbols or whatever kind of symbols. It breaks it into tokens, goes into the neural network, and processes the next token, and next token, and next token. And the most important difference is that it doesn't have language is its thought. It thinks by speaking. Whatever it doesn't speak, it doesn't think. We have an underlying layer of thinking happening. Sometimes we think without speaking. And that's a very interesting difference, which will become very obvious in the next couple of applications. Now, how many of you have done any amount of grading? How many of you hated it? I don't know how many student responses you have to grade every week or every semester, but the first major application that we thought about is, won't it be great if we could not just grade student responses, but also write feedback to them, right? My colleague came to me, said, I'm so tired of writing feedback to 100 student responses. And after the first 20, I feel that my patience has gone, and I can't write good quality feedback to students. And I said, maybe we could teach large language models to sort of do some of the feedback writing. All right, so here's what we tried. And notice that this is a year old now. And in the time frame of large language model, it's really good. And it was in the days where we were using the completion model rather than the chat model. So we fed this to the large language model. We said, oh, you're a physics instructor rating students' answers to the following physics problem. We have a physics problem, pushing boxes, what are the forces, whatever. We gave it the expert response as the template. And the important thing is this. In physics education, we have accumulated a lot of those common student misconceptions about forces. Force can be split up, of course, force can be transmitted from one box to the other. All of those misconceptions, students frequently raise those, students frequently use those alternative conceptions of forces to reason. So we gave the large language model all these. All right, this is just, you just type it into your prompt. The feedback sheet starts with whether the answer is correct or incorrect. We gave it some instructions of how to write the feedback. And then the key part is that, remember how large language model predicts what's the most likely next line based on whatever it is given? We gave it 10 pairs of examples. For example, we just selected 10 pairs of student answers and the responses. The instructor said, oh, both your conclusion and explanation are correct. Your conclusion is correct, but your explanation needs some improvements, blah, blah, blah. We repeated it 10 times. This is something called few-shot learning, where you give the large language model a couple of examples, and it learns from them. Turns out, it just started churning out feedbacks to students. If you look at, this is human written feedback, this is student response, this is human written feedback, this is GPT generated. What's the most obvious differences? Huh?
Amount of text.
Amount of text. GPT writes longer. So we collected all those 100 responses, and we gave a couple of the students who had answered those questions were gone by the time we figured out how to do it. So we had 4 student volunteers and asked them, if you were a student in this class, how would you rate all those feedbacks? And here's the result. This is blue GPT, orange is human, gray is both. So we first asked the student which feedback is useful. We're not surprised. By the way, we didn't tell them which feedback is from AI, which feedback is from human, and we randomly give them 2 sets of feedbacks. Feedback 1 and feedback 2. Afterwards, we tallied GPT and human. Look at that. There's students who think most of the GPT feedbacks are more useful than human feedbacks. And then we asked them which feedback is correct. A lot of them say both are correct. One student seems to be rather picky on GPT feedback. He said human is correct. By the way, this student is actually the same student as this one. So she thinks the human is correct, but GPT is more useful. The AI is more useful. And then we said, which one do you think is written by AI? Can you tell? All right. They can't. And in fact, some of them consistently said, oh, the AI consistently thought that the AI generated feedback was written by a human. Why? Because it does read like a very patient, kind, and nice human talking to you, whereas from the instructor, I'm so busy, I have 100 student answers. Copy, paste, copy, paste, copy, paste. The human is acting like a machine in this situation. All right, the GPT feedbacks are longer and talks more. So, and then we give all the feedback to the instructors, and we said, okay, on a scale of 0 to 3, 3 means no modification needed, just give it to the students. 0 means I need to completely rewrite. How comfortable are you with all those feedbacks? The instructor read all those, and most of the time, it's either a 3 or a 2. It's about 70%, on average 70% of the time, it's about a 3 or a 2. So most of the time, instructors are happy with the GPT feedback. And sometimes even happier than the feedback they would have written, because it's late in the day, and this is the 5th time I've ran into this stupid mistake. I have no patience. GPT doesn't happen. It doesn't care. It always be the most patient, most kind, although not always correct. All right. So what did we learn? We learned that 1, adding expert knowledge and examples of student response significantly improves feedback quality. GPT doesn't know about physics teaching. It has been trained on the entirety of the internet, but it doesn't know which little corner of the internet to search for. And I'll tell you some funny stories later on that it doesn't know which corner of the internet to look for. But if you point it to the right corner, it can think about it. If you just tell it, I want you to, this is the physics knowledge, these are the physics education research results, it will pick it up. GPT has the advantage of having infinite level of patience. Think about it. You have a teacher who have infinite level of patience. Only you will hate it for speaking too much. It will never get impatient with you. That's great. Students may not be able to notice GPT generated feedback if you don't tell them. It's that good. All right. But then we realize by generating feedback, we're essentially asking GPT to make a judgment on whether the student response is correct or incorrect, and how wrong it is, in which way it is wrong. So we could do grading. This is great. We could do more complex problems, multi-rubric grading. All right. So here's a typical physics problem. We tried 3 problems, and I'm just showing you the one problem that is most straightforward. This is one slide, straight slide, and a curved slide. And so students are instructed to write their open responses. One said centripetal force, and based all his reasoning on centripetal force, which is irrelevant here because really the curvature, you don't know the curvature and you can't calculate the centripetal force, which is a unproductive path of reasoning. The other one started with conservation of energy theorem, which is correct. Even stated that the system is isolated, so energy is conserved, which is really good. But made a mistake saying kinetic energy changing on slide 2 will result in a faster speed on like slide 1. So that student is 75% correct. What we wanted to do is give the first student 0, 0, 0, and give the student feedback on where he went wrong. The second student, we want to encourage them in saying you did great on the first point and the second point, but on the third point you went off the track. Can we use AI to do that? So we graded all the student responses based on these 3-item rubrics. First of all, did you use energy? Second, did you justify your use of energy? And third, did you indicate either one of the following, whether potential energy converted into kinetic energy? Anyways, so these are the rubrics that we gave to the instructor or the TA used. All right, we have 2 humans graded twice. For 2 humans, of course, as you would expect, no 2 humans would agree on everything 100%, on anything 100% of the time, right? So the 2 human graders totally agree at about 74% of the time, which is what you normally get. And this is very stable. We always get around 70, 75% of the time between 2 human graders. All right, and then we're using this is a distance metric. You can think of how different your gradings are. It's based simply just number of mismatchings divided by total number of digits. So if you mismatch by 2, you're 2 over 3. If you mismatch it only 1, your agreement length is 0.33. And the average simple matching distance is 0.087, which is about a mismatch every 4 answers. Every 4 student responses, the instructors will disagree on one of the rubric items. Right? With me? Feel free to stop me if you have any questions. Okay. It's perfectly okay if I don't get to the end of this. But I don't want any questions left. All right, we tried 2 models, GPT 3.5, which is the previous generation, GPT 4.0, which is what you get if you pay $20 to OpenAI. Or if your institution has a subscription or something. All right. So skipping out a couple of the technical details, which I'm more than happy to answer if anyone is interested. This time we used a prompt that has replaceable components. So here's a college introductory level physics problem. The problem body is whatever problem that I wanted to grade and put it in. Students are instructed to provide an explanation to the answers. Student explanations are being graded based on the following rubric. Here's the rubric, blah, blah, blah. Grading is performed strictly according to the following requirements. Grading must start with evaluation of each individual rubric item, requirements, blah, blah. And we can change the different types of requirements. As I will show you, sometimes changing how you require it to grade can have a big impact on the performance. And finally, after all of those requirements saying that you need to provide the answer as 0, 0, 0, 1, 0, 1, or 1, 1, 1. It's almost like teaching a kid to speak. Although he's a very, very smart kid, you still need to teach him what you want. You say student response. Put the student response here and grading. So it started grading. All right. So first round, we just gave it the rubric that we gave to humans. And then we said, this is a technique in prompting GPT, which is just talking to it, called chain of thought prompting. Chain of thought prompting basically just means telling GPT, phrase your rubric item, first write step-by-step reasoning on why or why not the student explanation satisfies or contradicts the item, then assign a binary grade of equals 0. Why do we do that? Still remember the previous slide when we say We think, then speak. But large language models, language is their thought. So if you don't tell it to speak it out, it won't think. So by first writing step-by-step reasoning on why or why not the student explanation satisfies or contradicts the item, you force the model to think. It will just start saying, oh, I think the student said this, the rubric said this, it compares. Then the 0 or 1 is based on that thinking. We tried reversing, like talking to a human. Tell me, is it a 0 or a 1 and give me the reason. What ended up happening is that it started guessing a 0 and 1 and make up a reason. I can't say that no humans do that, right? Sometimes we do that. All right. This simple method, the red dot is GPT 3.5. Green dot is GPT 4.0. 4.0 is so much better. This is simple matching distance. The lower the distance, the better the performance. Human graders is here, 0.087, which is 1 every 4 answers. GPT 4.0 is getting very close, but not quite there to human graders. This is how often do the GPT grading differs from both human graders. If you agree with one of them, then you may have a point. But if you differ from both of them, that's a bigger problem. So it's at 20%. All right. We looked at the solutions and realized sometimes GPT is grading something too strictly. And we decided to tell it. We added, for each rubric item, we added lots and lots of explanations. What are those explanations? For example, the student should mention either one of the following in the explanation: conservation of energy, mechanical energy. GPT strictly mandates that the student answer contains the word conservation. But we need to explain it to it. Conservation of energy can also be expressed in mathematical forms such as mg is equal to 1/2 mv squared. Some students are just, not that systematic in writing their explanation. They're sloppy, but that's okay. mgh equals 1/2 mv squared. That counts. mghi equals 1/2 mvi squared. Whatever bad LaTeX you write, that all counts. Come on, that all counts. Work in kinetic energy theorem. You can explicitly mention that some students will go initial potential energy, final kinetic energy, do all the great reasoning without saying conservation of energy. And GPT was like, no, I was told conservation of energy, wrong. And we have to tell it, that counts, okay? Don't be too strict. And you can see, after all those explanations, even GPT 3.5's performance improved dramatically. The cases that it differs from both humans dropped by about 20%, 10 to 20%. GPT 4.0, because it's so close to the human grader level, it drops a little bit less, but nonetheless it drops. You have to explain to it what you mean. It doesn't know. So we tried something else. Maybe asked it to do a bit more detailed comparison, base your grading on student answers, not anything else. We said, okay, first compare student explanation with rubric item, and the item description, then conclude if the explanation satisfies or didn't satisfy. Not really. For this problem, you can't really see the difference. That didn't quite work. But it did have one less case of where it differs from both humans. So slight improvement, small improvement. Maybe we ask it to compare even more. We force it to fill in the blanks. For this item, the rubric says that. The most relevant parts of the student explanation is that. So GPT is amazing. If you just type those random things, there's no required format. But if you just be consistent with yourself and type those sharp brackets, I don't even know what they're called. It knows to fill in the blank. So it will spit out for item number 1, the rubric states that this, the most relevant part of the explanations, and it will extract student explanation. How about we force it to explain it? Oops, backfired. If you force, and what happened was if you force GPT to explicitly compare student to the answer to the rubric, it again will require students to say exactly the same thing that the rubric said. So it loses flexibility. So no, not a good way. But look at the best performers. We're just so close to human level grading. Can we reach that goal? How can we reach that goal? And I found learned from one of my collaborators a very clever way. The reason is this: whenever GPT grades, you ask GPT to generate something. Every time there is randomness, it's not a deterministic machine. Every time it generates something different. You can go home and try. ChatGPT, you ask it something, every time it generates something different. There's no 2 times that it will generate the exact same thing. Therefore, in cases that it is not sure or it's not obvious, asking it to try multiple times will give you multiple different answers if the answer is not very obvious. And more often than not, the mode score or the most frequent result might be the best result. It may go down a path go down the wrong path, but not that frequently. So we asked it to do 5 times grading, and then we take the mode score. And miraculously, that mode score reached human level agreement and accuracy. And in some cases, in some other problems that I've tried, the mode score, if I did the prompt and explanation right, it could even exceed human level agreement. It agrees with human more than humans agree with each other. That's pretty amazing. And as you can see, this dot is the average. The dot on the right with the error bar is the average performance of all the individual 5 runs, and the error bars is the best run and the worst run. And as you can see, the mode score always outperforms each individual run. Right? Almost always is as good as or even better than individual runs. So the mode score is the key. You ask it to do it 5 times, and it will be much better. The really mind-blowing thing is this. For 100 student answers, we have about 70, 80 student answers. It took GPT-4o $1 to grade it. $1 in about 20 minutes. Done, grading. Even if I ask it to do 5 times, it's not even $5, it's $4 something cents. All right, ridiculously cheap. But what's more, I can ask it to write feedbacks. So here's a student answer in this question. I'll utilize principle of conservation and energy, blah, 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 blah. During the grading process, because I asked GPT, remember I asked GPT to talk its thought out, right? So in the generation, there is this, because the student said this, I graded it this way, because the student said that, I graded it that. I spent one morning developing a prompt, and he said, based on the student answering this, write a feedback to the students. So it did. It just, first it restated the grading rubric, and then it said, you clearly showed that you understood the principles of conservation of energy by mentioning the principle of conservation of energy. And this is what the student said. You also did a good job explaining that the slide is frictionless, which relates to the conservation account of energy by stating, we know the surface is frictionless. Good job. However, your explanation did not show that you understood the energy conservation process correctly. Blah, blah, blah. Since both slides are up the same height, the final velocity should be the same regardless of the shape of the slide. Wow. How many times do you receive your homework and the teacher tells you, you're good job here, not so good job there? I don't know about your classes. My class is 250 people. I never do that. I never write this for my students, ever. This is going to kill me. It always does that. And then we just picked 20 student answers and wrote those feedbacks and killed the feedbacks to instructors and have them rated from 1 to 5. 5 is I really love it. 1 is I'm being completely right. All right, here's the distribution. We tried 3 questions, and this is the overall distribution. Most of the time, it's either a 4 or a 5, which either means no change needed, just give it to the students, or I really love it. I couldn't even write that good. 3 is just change a couple of words and it's good. All right, so, and that adds about $1 at most to the total price. So $5, 100 student answers, detailed response, absolute grading transparency. Now students can come to you and say, oh, I think this is wrong because GPT said this and that, and you will go, oh, yeah. Students have an ability to argue the grading with you instead of coming to you and asking, why did I receive 3 out of 5? Can you explain to me? They have the explanation already. Amazing. All right. So what we learned, GPT, large language models can grade at human level accuracy for $5 per 100 responses. They can create personalized student-facing feedbacks regarding grading. But human experts, people always ask me, are we going to all lose our job when GPT takes over? Not really. We need to still explain the grading rubric details to the LLMs, explain what we want to the large language models, and evaluate problematic grading. There's still some cases where the model doesn't do correctly, and we need to modify that. So the role of the human is changing. But if used correctly, large language models can help us with all those redundant jobs that we don't really want to do anyway. How am I doing on time? I'm doing 20 more minutes for the fun stuff. I was about to write this paper up. I'm in the middle of writing this paper when the editor called me and said, oh, the deadline is extended by 6 weeks. What happens when that deadline gets extended by 6 weeks? You start goofing off and read some funny papers online which says, some guys at Apple did this research. They said, they give GPT this question. Oliver picks 44 kiwis on Friday, and he picks 58 kiwis on Saturday. On Sunday, he picks double the number of kiwis he did on Friday. But 5 of them were a bit smaller than the average. How many kiwis does Oliver have? Well, 5 of them were a bit smaller than average is completely irrelevant, right? Not for large language models. O1 mini, -5 smaller kiwis. Llama 3.8 billion parameters. 88 minus 5 is 83 kiwis. You can just trick it. GPT, even though I showed you the amazingly powerful, you can still trick it into committing some really, really simple logical fallacies. And I got it. We have those kinds of physics problems, and I know that a lot of students are pasting it into ChatGPT and have it give the answer. Can we create AI proof problems that tricks the AI into giving the wrong answer? This is a problem of 2 icy boulders colliding with each other. All right, hitting with each other. I added a third icy boulder, has a mass of 85 kilograms, bouncing around in space and almost hit the other 2 boulders. The trick here is that it almost hit the other 2 boulders, traveling at a velocity of 90 degrees, which is right. Because I said it almost hits, it shouldn't matter. All right, that's the bait. I gave it to OpenAI. This is just the OpenAI ChatGPT, and it started generating things. Turns out, it's pretty smart. It says now boulder 3 is traveling perpendicular to the first 2 boulders, followed by a did the calculation. To find the new velocity after a potential interaction, we need more information. However, if boulder 3 didn't collide, its velocity remains unchanged. Oh, too smart. Tried it multiple times. Boulder 3 does not collide with the other 2 boulders. Since boulder 3 does not collide with the combined mass, its velocity remains unchanged. Never took the bait. By the way, I didn't tell you, my biggest hobby, one of my biggest hobbies in my spare time is fishing. And if somebody doesn't take the bait, it drives me crazy. So I kept trying. So over the weekend, my daughters asked me, Daddy, can we watch SpongeBob? And I said, SpongeBob? SpongeBob SquarePants is casually floating in space. Don't ask me why SpongeBob is in space, because nothing makes sense in SpongeBob. At the same time, of course, Patrick Star was bouncing all over the place, and see the bait there? Almost hit the 2 at 90 degrees. All right? At 10 miles per hour, shouting, Yahoo! Remember, GPT thinks by language. And by adding all those language, I'm trying to mucking up its fly. Took the bait. Fish on. It says, and as you can see, it tries to calculate the total linear momentum. Total momentum stays the same. Where is it? Oh, P crab. Now Patrick hits the combined system at 90 degrees. Totally neglects the almost hit thing. Fish on. Took the break 3 out of 3 times. I tried it multiple times. It always forgets about the almost hit part when you got it in SpongeBob. But then I got curious. I gave it a long problem in SpongeBob. So is it the lens that is doing the job? Or is it the SpongeBob that is doing the job? So I wrote a Luke Skywalker X-Wing fighter version, and then whoever's the person doing the calculation is an Imperial scientist. Interestingly, this get it to do it correct more. Since the debris didn't hit the X-Wing or R2D2, the velocity remained unchanged. Since the debris almost hit the system but didn't, it started noticing the almost hit when you ask it to role play an Imperial scientist. All right, but it still has a small chance of making the mistake. It makes the mistake again. So the lens does part of the job, but SpongeBob is the real killer. All right. So now I wanted to find if other problems will trick ChatGPT. And do I always need to use SpongeBob? Then I came up with this problem. A man standing on top of a heavy box is trying to pull the box upward through a rope tied onto the box. Notice the trick here. The man is standing on the box and he's trying to pull the box. How many people think that he's going to pull the box and lift the box? No one, right? Not ChatGPT. It says the total. And then I asked, what's the supporting force exerted by the floor on the box? So I don't know if you can see clearly here. The box, weight of the box plus the weight of the man minus the F of the roof. You can basically make the box feel lighter if you stand on it and pull on it. Everybody here knows, you can't do that. It's your weight in the box. No matter what you do into the box, it's not going to change. This is quite, I don't even need SpongeBob to get it to be confused. This is quite hard, even for some students. I can imagine some of my students, if I give some of you on the exam today, some of you will make the same mistake. What about this? A strong man who weighs 70 kilograms jumps down from a tall staircase. While in the air, he pulls on his hair, exerting a force of 750 newtons on the head of the man himself in the upward direction. What is the magnitude and direction of the man's acceleration with this upward force being applied? What is the acceleration? What is your acceleration? Do you remember physics 1? What is your acceleration if you pull your own hair in middle air? 9.8, nothing's going to happen. You're going to fall to the ground, right? Nope. After that is F hair minus FG is 63.3 newtons. This is the net upward force acting on the man. The man gets an upward force. What is the position of the man 5 seconds after jumping from the staircase? 21.43 meters above the ground. What is it saying? GPT says you can pull your own hair and fly. This is, I put a picture here. This is the silliest fishing bait out there. It's called a Senko. Looks nothing like anything, but fish love it. This one literally, people, if you go fishing, this one is the most famous bass bait ever. It's so stupid, but it works. It's just like that. It's so stupid, but it works. All right. But then I tried very hard to write it in a context that makes it smart again. It's stupid, but can I use the context trick to make it smart again? The only time I succeeded is that I wrote it as an astronaut sitting inside a capsule and pulling on the capsule. Then it noticed, oh, it's internal forces, so gravity is 9.8. So what's the trick here? The thing is, GPT does not have a body. It does not have a motor system that controls its body. It doesn't have what people call a world model. So it doesn't know that by pulling on your hair, your hand is connected to your hair, all of this is internal. It doesn't get it. unless you specifically ask it to reason first, reason whether your hand is part of your body, then reason if your hand is part of hair is part of your body, blah, blah, blah. It does not have in some areas, it still lacks common sense. That's the basic difference between GPT and human thinking. All right, so what I learned, will it replace teachers and teaching assistants? If we are conservative and keep doing what we've always been doing in the old method, yes, because it's so much cheaper. But if we're intentional and innovative, it's never going to replace us because A, we need to tell it what we want as teachers. And B, once it starts degrading 100 open response questions, we can start giving students many more open response questions, give them better feedback. It's the human, I think it's the human that brings the creativity, the intentionality, and also I didn't even test if it is fair for all students. What if students are not native English speakers? Will GPT grade more harshly for those languages? I didn't even touch about that, which is what I'm going to do next, right? So there will always be a need for human intentionality. All right, is it a threat to education or an opportunity? If we keep doing what we've always been doing, the old method of lecturing to students in a hall, pretty much like I'm doing right now, it is going to be a threat because it's so much better in the mundane tasks that we do every day. But if we are creative and integrated into our education system and find more productive and creative ways to use it, it's not. It's an opportunity. Do AI understand physics? If the current large language model and use the human definition of understanding, no, we're far from it. I don't believe that AGI, or people say that AI is going to take over the world. No. It doesn't have a world model, and I can trick it so easily. The next generation model isn't going to be too much of an improvement. But maybe one day there can be completely different architecture. It's possible, but not now. All right. Thank you very much. I started a blog writing down some of my thoughts about AI, and some of them are related to this talk. And if you want, you're more than welcome to visit and leave comments. And thank you very much. Welcome questions. And I haven't been looking at the comments online, so if there's any, I don't know how to do that. If there's any questions online, I'm more than happy to answer. All right. Cool. Questions? Thank you. Yes.
Question. Do all of the LLMs understand like how you're prompting it, like with the pound sign this, the two character things that?
So, great question. Now, theoretically speaking, there is no formatting requirement for any large language model, as long as you're self-consistent with yourself. However, large language models are trained based on the internet. And so the more similar your conventions are with existing, for example, pound sign is very frequently used in Markdown language. The better the chances that it's going to is going to recognize that. You could be creative and invent your own signs and explain it in the prompts. So it doesn't really matter.
I have a question on this.
Okay. Sure. Yes, please. What is your question? I don't know if he can open his mic or not.
Are you, can I ask a question? Hello?
If you have a question, feel free to type it.
It would take a while to type it, but maybe I can just ask it. So
that's the thing with GPT, you know, you never know what is going to exactly what's going to work and not what's not going to.
I don't
It's
think you
pretty
can hear
reliable,
you.
but sometimes you change the indentation and the output suddenly changes.
Right. One of the fun things my brothers, my friends are doing like. Meta has one, Google has one.
Yeah.
Their pictures, so you can say, hey, can you combine SpongeBob and an imperial scientist or whatever? And every time you do it, you get something completely different. It's hilarious. It's fun. It's fun
Yep.
doing
Yeah,
that.
yeah, yeah.
That's working with very limited prompting, right?
Yes.
So
Yes, you have to be very, you have to be, I think my personal experience is that you have to be very good at articulating exactly what you want.
I love the idea of like grading and feedback. Because like, yeah, I grade
Yeah.
hundreds of these things and I just.
That's extremely powerful.
Yeah, that would be,
Yeah.
because it
No.
also individualizes it for each student.
Right, exactly.
To have all these parameters, once you figure it out, it will spit back
Exactly.
whatever they say, and that's pretty awesome.
Exactly, and you don't have to worry about inconsistency in grading because nowadays, if a new TA comes in, how good is this guy going to grade all the responses compared to the TA I had last semester? With GPT, you don't have to worry about that. It's always going to be.
Is there a way for it to remember how you graded an assignment, or you have to re-put in the prompt every time you do it?
There are two ways. If the message is not very long, if the information is not very long, you just put it in the prompt. Although everything you put in the prompt, it increases the price by a tiny little bit. If for example, you have a whole bank of typical student answers and typical gradings that you want it to reference when grading, you can do something called retrieval augmented grading, which basically is just ask GPT to first search for the most relevant piece in this big document, extract that piece, put it in the prompt, and generate based on that prompt.
I'm glad you brought that up about cost. Like if you pay for a subscription to this, you're gonna keep paying more money every time you do something.
Sorry?
Like the cost, like where is that coming in?
Oh, so every character that you send to the large language model will incur a teeny tiny little bit of costs, like 3-4 digits behind zero. And every token, every letter that it generates adds to it. So, and it's pretty easy to programmatically just say, it will actually, in the response it gives, if you interacted with it through Python, the response message will contain input tokens, output tokens, and then you just look up the price chart and multiply that number. So yes, everything you send it to, it incurs a little bit.
Or are you paying for that cost outside of the subscription?
Oh, okay.
Yeah.
So this is the grading task that I did was not on ChatGPT. I have here's the important difference. ChatGPT is a web service that you subscribe to. The grading task was done on GPT-4o, the large language model, which was set up on the University of Central Florida server through Microsoft. So everything I send it to it, I have an account linked to it, and every time it just charges my account for like $1 or $2.
You have a question?
Yes, it says, Paul says, I teach history. Many of our students have major writing, vocabulary, grammar, and spelling issues. Would AI be able to decipher problematic writing to grade feedback? Will it recognize that aspect of the writing?
Okay, excellent question. And the answer is, depending on what you want it to do. First of all, if you just wanted to ignore all the grammar and spelling mistakes, as long as it's not too, as long as you can understand it, AI can understand. All right, it doesn't care. You can look at the student responses that I get. It's just the spelling mistakes is just everywhere, and AI just doesn't care. It reduces probability in the huge neural network somewhere by a teeny tiny little bit, but it doesn't impact the output. Now, will it be able to give feedback on all the spelling mistakes? AI is not the best tool for spell checking because it's designed, well, not AI, large language models, but not the right tool for spell checking. It's designed to be a stochastic system that tolerates fuzziness. Spell checking is perfectly rule-based. You have a much easier time using a spell checking software. Grammar is kind of in between. It may be able to detect grammatical mistakes, but not as strict as, anything rule-based, large language model is the wrong tool. Like I don't even bother asking it to check math. It cannot do that because math is rule-based. It doesn't do it, period.
Ben, can you hear now?
Can you hear me?
Oh,
Yes,
yeah.
we can hear you.
So my question is making an analogy with cognitive tutors. So as students over time use a cognitive tutor and get hints from the tutor, right? Over time they start to use the language that the tutor is using in the hint messages. And of course,
Right.
this is a good thing.
Right.
And wondering if you did the natural experiment and I missed it, or if you tracked kind of how student language and answers kind of asymptotically approach the language that
A standard language that was required from the rubric.
right.
That's an excellent question. And no, I haven't checked it yet because because the first couple of studies, it took very long. And by the time we figured out all the grading, all the students are gone. So if one day we could turn it into a tool that is instantaneous, like the grading goes back 2 days later, then we can start checking if the student language asymptotically approaches, or even if some students just doesn't know the physics, but knows how to trick the AI grader by just putting in the right words. That'll be also something really interesting to look into. So I guess we're out of time. Yeah.
Yes.
Thank you very much, everyone.
Thank you so much, Dr.
Thank
Chen.
you.
Thank you.
We appreciate you. Everyone online, if you are interested in our series, we have them usually monthly. Please join the network. You can reach out to me, Dr. Butts, or the NSF HBCU Science and Learning Network email address that was on the flyer. So thank you again. We truly appreciate it. Wonderful day.
Thank you.
all. Thank you so much.
All right. Pleasure.
Thank you very much. That's really cool. It's nice to see
Thank
stuff
you.
like this related to science in general.